In this video, we're going to talk about the review problems from Chapter 7, the properties of real numbers. First problem in the cumulative review for Chapter 7 is problem number 51. It asks us to tell whether each of these numbers in the list is a whole number, an integer, a rational number, an irrational number, a real number. So number 5, or the number -5, is not a whole number. It is an integer. It is a rational number. It is not an irrational number, and it is a real number. Number -2 1/4, which could be written as -9 quarters or -9 25 hundredths, is not an integer. It is rational because it can be written as a fraction. It is not irrational. It is real. Okay, it was not a whole number either because it had a fractional part. Number -√4 is the same thing as -2, which is the same thing as -2/1. So that is not a whole number, but it's an integer. It's rational because it can be written as a fraction with a denominator of 1, and it's real. The number 0.25 repeating is the same thing as 25/99. That one is not a whole number. It's not an integer. It is rational, which means it's not irrational, because rational and irrational are, if a number is rational, it's not irrational. If it's irrational, it's not rational. So, and it is real. Okay. And then the last number here, we've got 2 more. So we've got 13/5, which is the same thing as 2 3/5, or 2 6/10. That number is not a whole number, not an integer. It's rational, and it's real. Okay. And then the number 4, +4, is the same thing as 4/1. That is a whole number. It is an integer. It is a rational number, and it's a real number. Okay, so we had no irrational numbers in our list today. Examples of irrational numbers might be things like the square root of 2, the cube root of 5, pi, e, and so on. Those would all be examples of irrational numbers. Irrational numbers, remember, are non-terminating, non-repeating decimals. Okay, so square roots, cube roots, any other root that can't be simplified down into an integer value, things like pi and e that can only be represented by letters or symbols like that, are going to oftentimes be our irrationals. So let's keep going here with number 52. 52 asks us to simplify 8/15 plus 4/7 plus 3 over 7. I'm going to use my associative property here to regroup because it's all addition. This 4 over 7 plus 3 over 7 gives me 1. So that's 1 and 8/15, which is the same as 15 plus 8 over 15 is the same as 23 over 15. So I will take either 1 and 8/15 or 23/15 as a final answer. Let's keep going here. For 53, asks us to simplify 3 times y plus 3 minus 8 times y minus 4. So we're going to use our distributive property here. 3 times y plus 3 times 3 minus 8 times y minus 8 times -4. It's going to give us 3y plus 9 minus 8y plus 32. I'm going to get my y's together. And I am going to get my constants together. And this is going to give me -5y plus 41. 54 asks me to simplify 8 over 17 times 49. I'm going to put that 49 over 1 times 17 over 8. This 17 goes into that 17 one time. This 8 goes into that 8 one time. That leaves me with 49 over 1, which is 49. 55 asked me to convert 55 feet to yards. There's 3 feet in 1 yard. Feet needs to go across from feet so that they cancel. Yards is what I want to keep. That needs to go in the top. 55 divided by 3 is 3 goes into 5 one time, 2 left over. 3 goes into 25 8 times with 1 left over. That's 18 1/3 yards. That's 18 yards, 1 foot. It asked me to change it into yards. So let's keep it all in yards. Okay. Let's do number 56 now. Number 56 says that every day last week, Amit recorded the number of minutes that he spent reading. It gives us all of those minutes. It wants us to add them all up. 48, 26, 81, 54, 43, 62, 106. So 14 and 1 is 15 and 4 is 19 and 3 is 22 and 2 is 24 and 6 is 30. 0 carry the 3. 3 and 4 is 7 plus 2 is 9 plus 8 is 17 plus 5 is 22 plus 4 is 26 plus 6 is 32. I end up with 420, and these are minutes. Better put my units there. Okay. Last problem is going to be a calculator problem. June walked 2.8 kilometers. They're going to give us a conversion factor to ask us to convert kilometers to miles. They tell us that there's 1.61 kilometers per mile. So we're going to take 2.8. We're going to divide it by 1.61 to get our answer. And And we're going to approximate this with our calculator because it's not going to come out exactly. So make sure you use an approximately equal to sign. I'm going to pull up my calculator on screen. I already did this problem earlier. You can see that the answer is about 1.74 miles. Again, this is division because 2.8 was in the numerator, 1.61 is in the denominator. You have to line up the kilometers across from the kilometers. That's why we're dividing. And because this did not come out evenly, we're just going to round it to the nearest hundredth unless the problem tells us differently. In fact, let's talk specifically about why I would, I might actually round this if this is in science class. I'm going to use significant figures here. Let's talk about significant figures for a second to actually get better rules about how we should round. This one has 2 significant figures. And this one has 3 significant figures. So we can't be any more specific with our answer than the one that had the least number of significant figures. So we're going to round this actually to 1.7 miles because that's going to give our answer into significant figures. That way you're not guessing. There's actually some rules that tell you with multiplication, division, don't be any more specific than the one that has the least number of significant figures. And in that case, we had 2 significant figures there. So that's how we're going to determine where to round. Since no rule was told us to round to the nearest 10th or 100th or 1000th, we're going to use our significant figure rules. Okay, that is it for the Chapter 7 problems. See you next time.